We're going to talk about what solution stoichiometry is and how it compares to gas stoichiometry and regular stoichiometry equations and calculations. We have 3 or 4 examples to go through to show the ins and outs of different things that we can calculate and determine from certain information that we're going to be given. As always, this is our flow chart. So everything goes through moles. And if you want to get from one type of mole, be it a reactant or a product, to the other mole in the calculation, you need to do a mole ratio, and that would be my center arrow. So we have to be mindful that this is really an important step, and that is going to be our coefficients in our balanced equation. So let's take a look at how we can use our flowchart that we have utilized many, many times with some equations and questions that might look a little new to us. First question, it says that zinc and hydrochloric acid react according to the following balanced equation. What mass of zinc will react with 2 liters of 0.25 molar hydrochloric acid? This is very important to organize your information. So let's do that. It says what mass will react of zinc? So that is my question. Then it indicates that I have 2 liters of hydrochloric acid, and I have 0.25 for my molarity. So it appears that the blue compounds over here, the blue part of my flowchart is my zinc, and the red part is going to be my hydrochloric acid. And the only reason why I know that is that the zinc is definitely my question, and the hydrochloric acid, I have some information. So here we go. How can we utilize the information that we have? Well, if I take a look at this from what I know, if I have molarity equals moles over liters. And I already have the molarity and I already have the liters. So what I can do is I can find my moles, and I can land right there for my hydrochloric acid. So that's how I'm going to actually start this. So I'm going to set it up in that equation. So I have 0.25 molar equals 2 liters are on the bottom, and moles of my HCl are on the top. So now I can just solve for that portion of my molarity equation, and hence solution stoichiometry. So I'm going to have 0.5 moles of HCl. So if I told you I had 0.5 moles of something and I wanted to find grams of something else, what would we do? We would start with moles of one thing, and then we'd find grams of something else. Nothing's different here. Same concept. So I have 2 more steps to go. So I'm at moles already. So now I need to do the mole ratio step. So for every 2 moles of HCl, I have 1 mole of zinc. Now I'm at moles. I need to get to grams. And how do I do that? I utilize the molar mass. So it'll be 1 mole of zinc, and then 65.3, let's say 8 grams of zinc. We calculate that all out. We get 16.35 grams of my zinc. So if I have 16.35 grams of zinc, that will be what was produced from reacting, or that will react perfectly with that solution of hydrochloric acid. So that is utilizing a molarity solution and figuring out the grams of another reactant using our flowchart. All right, our next question. Again, it's about organizing our information. So it says how much 0.20 molar H3PO4 or phosphoric acid is needed to react with 100 milliliters of 0.1 molar NaOH. Okay, so this one's a little different because what it's asking is how much. So when it says much and then it says a solution, usually what we can do is assume liters. Okay, we're going to try to assume volume there. So let's organize our information yet again. I have given myself 0.2 molar of H3PO4, and it says here that I have 0.1 molar of NaOH and 100 mils of that solution. So it appears that I don't know my volume. Now, this is important. It is not volume that's on here. These are for gases. Okay? What we're talking about right now are solutions. So what you need to do is figure out kind of what we have and what we don't have. Yet again, when I have molarity and volume, I can then determine moles. So I'm going to utilize the information I have from NaOH there. So I have 0.1 molar, need to have it in liters, a 0.1 liter solution of NaOH. All right, so what that's going to equal is 0.01 moles of NaOH. Okay, so think about this for a moment. If I have 0.2 molar of that, and I want to find liters, that means I have to find moles before I can solve for liters. So if I have moles of one thing, I can discover moles of another. So all I'm going to do in this one is simply a mole ratio. So for every 3 moles of NaOH, I have 1 mole of H3PO4. So that would be 0.0033 moles of H3PO4. Well, how does that help me? Well, now I can plug it in to my molarity expression. Again, this is of my H3PO4. So after all of that is said and done, I either get 0.0165 liters or 16.5 milliliters. Reminder, when solving for your molarity, you can always utilize the triangle. So I was solving for liters, so you cover up liters, and it's moles over molarity. So that is a unique problem because what it is, it's giving you information about 2 solutions using molarity, and all you needed was the mole ratio. That's all we were going to utilize on our flowchart this time. Again, liters for our flowchart are utilized only for gases at STP. Here's our next problem using an equation that we just had in our first problem. But again, let's organize our information. It says when you use 25 mils of a 4 molar HCl, so I'm going to write that down immediately. I have 25 milliliters of 4 molarity to produce hydrogen gas. What volume of gas, okay, it's going to be important, gas is produced at STP. So what volume of gas is at STP? So I'm starting, again, when I have molarity and I have volume, I need to get it into moles. So I'm going to go from moles, and then this time they're asking for liters. And remember, at STP, I can go down that track. So this looks like a 2-step problem after I get it into moles. So I utilize my molarity equation. Make sure that I'm in liters. And I'm going to solve for the moles of hydrochloric acid first, which is 0.1 moles. Now, 2 steps. First, mole ratio. For every 2 moles of HCl, I have 1 mole of hydrogen. Now, I have just gone through the mole ratio. So now I'm sitting at moles of hydrogen. And if I was going to grams, I would multiply it by the molar mass. If I was going to particles, I'd multiply it by Avogadro's number. But in this case, I am asking for volume of a gas. So at STP, it is 22.4. So you multiply that through, and you get 1.12 liters of hydrogen. So that is utilizing molarity and gases at STP, going and maneuvering through our flowchart. All right, here we go. Our final problem for the day. It says throwing some scrap iron in a gold nitrate solution causes the gold metal to precipitate, which is nice. You can actually get solid gold out of this reaction. How much 0.5 molar gold nitrate solution would react with 224 grams of iron? So if you had access to 224 grams of iron, it's wondering how much of the gold nitrate solution would you need. Again, when it's asking for a volume, or sorry, a molarity, and asks for how much, usually we assume liters, not mass. And it's a little bit different here. So I have 0.5 molar here, and it's asking for volume. Okay, so you again have to be you have to have a little vision here. Right here, molarity equals, well, I'm looking for volume, so that means I need to have moles. So I need to find moles, and it looks like I'm starting at grams, right? This is my iron. This is going to be my gold 3 nitrate. So it appears that I'm going to do 2 steps and then solve. So I have 224 grams of iron. I'm going to do 2 steps. So I just converted to moles. Now I'm going to do the mole ratio. For every 3 moles of iron, I have 2 moles of gold nitrate. And I get 2.68 moles of the gold nitrate. Now, you can do this a lot of ways. I'm actually going to try this time to actually just plug it right into my molarity problem. So I'm going to actually literally write it like this. Now, if that's confusing, because that is the setup, molarity equals moles over liters, we could get rid of that. Get rid of that line. And I could just start down below and say, okay, if I have 0.5 molar, this is how many moles I have of my gold nitrate, and now I want to find liters. We could plug it in like that as well. Regardless, when I'm all said and done, I'd have 5.36 liters of gold nitrate needed to react with the 224 grams of iron. So when we're given molarity, what we do need to recognize is that it's usually giving us moles of some sort, because moles is the only part of our flow chart that is consistent. The liters deal with gases, not an aqueous solution. So we have a worksheet we can start to work on and see how we can handle these problems.